Okie dokie, number 59 from section 2.3. So number 59 states in the directions, let's find it. Evaluate the derivative of the function at the given point. Use a graphing utility to verify your result. Okay, so we need to find the derivative of this function, which is 1 plus cosecant over 1 minus cosecant. We note that cosecant of x is equal to 1 over the sine of x. Also, because every trigonometric function can be written as a composition of sines and cosines, we will probably also need to know what cosine of pi over 6 and sine of pi over 6 are, because we note that that's one of the x value in our point here, right? So let's see. What we need to do then is to figure out what this derivative is. Oh, one more piece of information that we might need is what the derivative of cosecant of x is. And we can actually derive this, right? Because it's going to be equal to the derivative of, let's see, 1 over the sine of x. Right? Noting this, right? So we can use the quotient rule on this, and this is going to be equal to, if our up function is 1 and our down function is sine of x, the derivative, according to the quotient rule, will be down, d up, and the derivative of 1 is 0, minus up, which is 1 times d down, which the derivative of sine of x is cosine of x, and that's something that you're simply just going to have to memorize. And then divide that by down squared, which is sine squared of x. So this is going to be equal to negative cosine of x divided by sine squared of x. Now, you could leave it in this form because we know we have what cosine and sine are equal to, and we could use those, right? The way that you would see it written in the book is negative cosine of x over sine of x times 1 over the sine of x. All right? And that is, well, negative cotangent of x times cosecant of x. So, here we have, the reason that they do this is just so that you can express them in the simplest possible trigonometric functions, right? So, if you looked in theorem, what I think, 2.9 in the book, this is what they would have. So, but we don't need any of that. We just need the fact that it is equal to either this or this. So, let's erase that. And erase our work for that, because we don't really need it. We just need that the derivative is equal to this. Let me see if I can figure out real quick how to. Here we go. I figured it out. I can take this. I wonder if I could just move it. Yep, I can. So all we need is this fact, right? That it is equal to these things. And we'll move that. Right. And try to get a little bit closer there. There we go. And move it. Loop. And this whole thing, and maybe let's just move this fact right over to here. Right. Maybe even, let's see. Getting too playful with this now. And one last thing, we'll just move that right over there. There we go. Okay, so we have this fact now that we just derived. So Let's use the quotient rule now. Again, on this function, which was the thing that we originally wanted to take the derivative of. We just had to derive what that derivative was. So y prime is going to be equal to, again, down 1 minus cosecant of x, d up. So that's going to be the derivative of 1 plus cosecant of x. So derivative of 1 is 0, so that goes away. Derivative of cosecant of x, we just derived it, is negative cotangent of x times cosecant of x minus up, which is 1 plus cosecant of x times d down, which is just going to be derivative of 1 again, 0, times the negative of the derivative of cosecant of x, and the negative of the derivative of cosecant of x, since the derivative of cosecant of x has a negative sign in front of it, that comes out and makes this positive. Cotangent of x times cosecant of x. Right. And that will be all over the derivative of this, which is 1 minus cosecant, I said cosine, minus cosecant of x squared. Okay, one thing that we can notice here is that except for a negative sign, this quantity and this quantity are exactly the same. And if they are exactly the same, then maybe we can factor them out and make our whole expression a little less complicated. So that will be equal to, and you can choose which one that you want to factor out, whether or not it maintains its negative sign or not. So you could factor out negative cotangent of x, cosecant of x, or you can factor out positive cotangent of x, cosecant of x. Let's just factor out the positive and leave this negative in the first term. Why not? Okay, so that's going to become cotangent of x times cosecant of x times the quantity of, well, this first term with a negative sign that was left over right here, and whatever all the factors that are left, which is just 1 minus cosecant of x. And then we're going to minus, we already took this factor out of this term, so it's just left over with 1 plus cosecant of x. Divided by, 1 minus cosecant of x, quantity squared. This is going to be equal to, well, let's see, what do we got? We have cotangent of x times cosecant of x. We're just bringing this down. And let's simplify this out. So first we'll distribute this negative to all these terms. So I have negative 1 plus cosecant of x. Distribute this negative to both of these terms. And that's going to be minus 1 minus the cosecant of x. This plus cosecant cancels with this minus cosecant. And we have this all divided by 1 minus cosecant of x, quantity squared. This becomes, well, I just have this minus 1 and minus 1 there, which just become negative 2. That is going to be the only term inside of this quantity, so it becomes a factor of the entire numerator, so I can just bring it out in front. Negative 2 cotangent of x, cosecant of x, divided by 1 minus cosecant of x, quantity squared. And that's just about as simple as we are going to get this expression. So the hard work comes in figuring out what it is equal to when we are at x equal to pi over 6. So, because we're running short on time, I will prestidigitate the rest of the problem. So what I did right here, I don't know if I can see this. I wonder if I can make it into something. Yeah, okay. So what I did right here was convert everything into cosine and sine. I'd made a little mistake above here when I said that I corrected it here, that cosine of pi over 6 was 1/2 and sine of pi over 6 was square root of 3 over 2. Reverse those, right? So for those who are astute and can catch it earlier in the video. But with that correction made, I substituted in values of cosine and sine for cosecant and cotangent, and then just put the values of cosine and sine at x equal to pi over 6. So this right here is the same thing here, but with the values of sine and cosine substituted. So we get -2 times square root 3 over 2 divided by 1/2 squared over 1 minus 1 over 1/2 quantity squared. This might look daunting, but let's use some red here. Some red. This quantity right here, oh, I need a brush. This quantity right here, you can look at what's on the inside. So that's 1 minus 1 over 1 over 2. Well, 1 over a fraction, you just multiply by its reciprocal, right? Or you can just 1 over something is the reciprocal, so the reciprocal of 1/2 is 2, right? So you can just do 1 minus 2 squared, which becomes -1, and -1 squared is just 1. So this whole denominator here just cancels out to 1. So you can really just focus in on what's going on in the numerator, right? So here we have 1 square root of 3 over 2 divided by 1 over 2 squared. Well, what you can do with that is just multiply by the reciprocal of 1 over 2 squared, right? Because you're taking something and dividing it by some fractional quantity. Well, then you can just take multiply by the reciprocal here. So that 1 over 2 quantity squared just becomes the reciprocal of 1 over 2 squared, which is 2 squared. So that's pretty easy, right? So focusing in on just this problem right here, you can see that this 2 and that 2 cancel. So that just leaves you with -2 squared times the square root of 3. And so that's -4 times the square root of 3. And if you put that in your calculator, you'll find that it equals something approximating -6.93. So using that for the derivative, or the slope of the function at that point, we can throw it into this. We can find what the tangent line is for a slope of -6.93 that runs through a point of pi over 6 comma -3. And the only thing that's left to do is find the y-intercept, which is 0.628. So we will pick up the graphing calculator part in the next problem, or in the next video.